Okay, so this is a very brief video. The idea here is we had the book gives examples for the two additive models for Holt Winters with no trend and for with trend. But they also give formulas for the multiplicative models, but don't give examples. So I've just kind of adapted the examples to use the multiplicative models. I'm not going to build these from scratch, but I just want to quickly show you what I did. So this is the no trend multiplicative model. It's the gas usage data. Again, it would have been nicer if we had more periods. We would have got more kind of realistic parameters up here. So we literally have the first year for our initial estimates, so then we have our first set of forecasts. But just the difference with the additive is this is C6 over D6 rather than C6 minus D6, i.e. seasonality is multiplicative. We expect, just over twice the average gas usage in January and 0.3 in June. When I'm calculating the level, I basically, for the current, rather than our current usage minus the most recent seasonality for that period, I divide by the most recent seasonality for that period. So I divide by the most recent seasonality for January. And for the seasonality, again, for my current seasonality, I take my gas usage and divide by the seasonality. So it really is just wherever we subtract, we now divide, and wherever we add, we now multiply. So for our final estimate, we multiply by the seasonality. So exactly the same model, but just think subtract, divide, add, multiply. And it's the same with my the car sales data. You can see the graph here. There's very, very little difference. And you can see here that I actually did the solver parameter estimation beforehand. But again, seasonality, divide rather than subtract. When we calculate the level, again, for the current estimate of level, we take the current and we divide by seasonality. The trend isn't affected. The estimate of seasonality, again, we take the current and we divide by the seasonality. And the forecast, we now take level plus trend and we multiply the whole thing by the seasonality. So just a few interesting things. In both the additive and the multiplicative model, as I mentioned, this is the default parameter because we only have one year of forecasts and in these years of forecast, we actually use our default seasonality, which we created in the setup, which wasn't smoothing. If we used another year, then we could optimize this parameter. And we find in both models, the alpha equals 0 gives the best model. Like if I put alpha equals 0.5, and let's just click, then my mean absolute error, and you see my graph goes a little bit apart, goes from 14 to 18. So in this, and I think it's just the way they've generated the data for this, just almost calculating the averages gives the best model. And again, because the alpha is 0, this really doesn't, we get almost the same mean absolute deviation for this model, and make sure I put multiplicative, than the other model. Now, for this, we can actually compare the models. So I have my optimized model here. Again, we're doing a complete update of the seasonality. My initial estimates were maybe not that good. You see here the mean absolute deviation is 2252 in the additive. And the multiplicative, just let me update my titles after I updated the formulas. You can see here that the mean absolute deviation is 2296. Just make sure we actually have the right version of that. So just go data solver, solve H44 by altering my parameters. And yeah, I did this before. So this is 2296 for the multiplicative model, and this is 2252 for the additive model. So the additive model works slightly better in this instance. Okay, and that's it. Literally, I was just spending a little time just altering the formulas to give you the multiplicative version rather than